You know that feeling, right? The incredible frustration when something brand new just dies on you? And then there's that other feeling, that quiet pride in an old tool that has just worked every single time. That difference? It isn't luck, it's science.
So what's the deal? Why is it that some things seem built to last forever, while others feel like they were designed to fall apart? Well, the answer isn't magic, and it's not just quality. It's actually a very specific, very calculated field of engineering. So let's dive in.
And that entire field really comes down to one big concept: reliability. But hold on, this isn't just about that warm, fuzzy feeling you get when your car starts on a cold morning. In the world of engineering, reliability is something much more concrete. It's a number.
Okay, this is the textbook definition, but let's pull it apart because the key words tell you everything. See that? Probability, function without failure, for a prescribed period. This means reliability isn't a guess. It's a specific mathematical prediction about how something will perform.
It's so specific, in fact, that we can boil it all down to a single score, a number like this one, 0.95. And that number isn't just for a marketing brochure, it tells a very precise story about what you should expect.
So what does a 0.95 score actually mean in the real world? Well, it means there's a 95% chance the system is going to work like it's supposed to. But, and this is just as important, it also means there's a 5% chance it's going to fail. To put it another way, if you use it 100 times, expect it to work perfectly about 95 of those times. It's all about managing expectations with cold, hard data.
Okay, so it's a number. Big deal, right? Well, actually, yeah, it's a huge deal. It turns out this one concept has a massive impact on everything, from the money in your wallet to, your actual survival.
On the most basic level, reliability builds trust. It's simple, really. When something just works, every single time you use it, you start to trust the company that made it. That consistency is what turns you from a one-time buyer into a loyal fan.
And hey, it's not just about feelings, it's about cash. For us, a reliable product means fewer annoying trips to the repair shop. For the company, it means they're not bleeding money on warranty claims. In the long run, reliability just saves everyone money.
But this is where things get really serious. We're talking about industries like aviation, medicine, or even the brakes in your car. In these areas, reliability isn't a nice-to-have feature. It is a non-negotiable, life-or-death necessity. Failure simply isn't an option.
Now, this kind of extreme dependability doesn't happen by accident. It is meticulously designed and planned from day one. So how do engineers do it? How do you actually build something not to break? It all starts with two fundamental design philosophies.
Those two core ideas are called a series system and a parallel system. You can think of a series system like a chain. All the parts are linked together, one after the other. But in a parallel system, you have backups. Let me give you a really simple analogy for each.
Remember those old, cheap holiday lights? The kind where if one tiny little bulb burned out, the entire string would just go dark? So frustrating! Well, that is a perfect example of a series system. The whole thing is only as strong as its single weakest part. Now contrast that with a multi-engine airplane. That's a parallel system. If one engine were to fail, the other engines are right there to pick up the slack and keep that plane flying safely. That concept of having backups is called redundancy, and it's the secret to building incredibly reliable, critical systems.
So, we know how reliability is designed into a product, but how do you actually measure it and track it over time? Well, engineers have a kind of scorecard with some very specific metrics they use to grade a product's lifespan. But this brings up a really interesting question. Does it make any sense to measure the life of a car engine, something you can repair over and over, the same way you'd measure the life of a light bulb, which you just throw away when it dies? The answer, of course, is no. And because they're different, engineers use two totally different metrics. For stuff you can fix, they use MTBF, which stands for mean time between failures. For things that are non-repairable, they use MTTF, or mean time to failure. The whole difference is in that one little word, between versus to.
So let's make it super simple. MTBF is for repairable things like your car engine. It basically asks, on average, how long does this thing run between breakdowns? MTTF is for throwaway items, like a microprocessor or that light bulb. It's asking a much final question. How long until this thing's one and only death?
And that really brings us to the crucial point. That feeling of trust you have in a product you love, it's not a feeling.
It's not magic. It's the end result of intentional design, careful calculations, and rigorous measurement. It is, through and through, a science.
All right, so let's recap what we've learned. Number 1, reliability isn't just a vibe, it's a measurable probability. Number 2, it's absolutely critical for our safety, our costs, and our trust. Number 3, systems are built one of two ways, like a weak chain or with strong backups. And finally, we measure repairable things with MTBF and disposable things with MTTF.
And I'll leave you with a final thought. Look around you. Think about your life and the technology you depend on every day. What is the one thing, the one system that absolutely, positively cannot afford to fail you? Whatever it is, now you know a little more about the incredible science that works to make sure it won't.